In section 6.5, we are solving applied problems involving percent. The first exercise is the following: transportation to work. There were about 148 million workers in the United States in 2015. Approximately 9% of them carpooled to work. Question: how many workers carpooled to work? So familiarize ourselves with the situation, and let's say C is the number of workers that carpool to work. So C is the number of carpool workers who carpool to work. We can visualize this by saying, okay, let the whole circle represent 148 million workers in 2015, and then 6%, a little slice like this, 6% are the ones that carpool to work. So then we translate and ask, what is, what number is and is equal (9% of 148 million. So that's 9% of means multiplication, 148 million. When we use proportion, that's 9 over 100 divided by 100 is equal to C divided by 148 million. So we can solve this by saying C equals 9% of 148 million. Which is 0.09 times 148 million. Which is equal to 13,320,000. When we do proportions, we cross multiply. 9 times 148 million equals 100 times C. And then we divide both sides by 100 to isolate C, which is then equal to 9 times 148 million divided by 100, or 13,320,000 equals C. So whether we use proportions on the right, or if we just use the straightforward approach as we have done in the past, the number of workers who carpool to work is 30,320,000. We can check in two ways. Number one, we repeated the solution twice in different ways. One with a straightforward percentage application and one with proportions. we can also say 9% of 148 million. That's pretty close to 10% of 148 million. And 10% of 148 million is 14,800,000. And 14,800,000 is reasonably close to 13,320,000. So therefore we can state that so we state the number of workers who carpooled to work in 2015 was 13,320,000. In exercise 2, we have presidential assassinations in office, and it says of the 43 different US presidents, 4 have been assassinated while in office. These were James A. Garfield, William McKinley, Abraham Lincoln, and John F. Kennedy. What percent has been assassinated in office? So let's say P is a percent. So we can translate this as follows. We asked 4 is what percent of 43? Or as a mathematical equation, 4 is, of course, is the equal sign, what percent P of 43. Or when we use proportions, we use n divided by 100 equals 443, where n percent equals P. To solve this equation here, we write this as 4 equals P times 43. To isolate P, we divide both sides by 43. On the left side, then we have 4 divided by 43 equals P. So when we solve this equation, we divide both sides by 43, and 4 divided by 43 is approximately 0.09302, and then a few more digits, but we can just round it up this way, and then we round it up to 9.3%. And when we use proportions, we cross multiply. N times 43 equals 100 times 4. 100 times 4. Then to isolate n, we divide both sides by 43. So n is equal to 100 times 4 divided by 43. So n is approximately equal to 9.3. For the check, we can say, well, we did it twice and we came up with the same answer. We can also say that 9.3, that's close to 10%, so 9.3% is somewhat close to 10%, and 10% of 43, it's about, well, it's 44.3. So 4, the number who have been assassinated in office, is close to 4.3. So our calculations are correct. And so we can state that so about 9.3% of US presidents have been assassinated in office. In exercise number 3, we have a percent increase. We are told the price of a car is $36,875, and then the price is increased by 4%. And the A part asks, how much is the increase? And the B part asks, what is the new price? Whereas the increase for A, the increase is 4% of 36,875, which is equal to 0.04 times 36,875, and that's equal to 1,475. So the increase is $1,475. That's for the A part. For the B part, well, the new price is the original price of 36,875 plus the increase of 1,475. So we add these two, and that is equal to 0, 5, 3, 8, and a 3. So the new price for the B part is $38,350. So this is the original price, and this is the increase. So this is the answer for A, and this is the answer for B. Exercise number 4 states that the value of a car is $36,875. The car depreciates in value by 25% after 1 year, which, by the way, is fairly typical. How much is the decrease? The decrease is 25%, and 25%, so here's the A part, 25% is 0.25 of, means multiplication, 36,875, and that's equal to $9,218.75. So that's the decrease, the amount. And what is the depreciated value of the car? So that's for B. We need to subtract the amount of depreciation from the original value of the car. In other words, 36,875 minus 9,218.75, and that is equal to 27,656.25. And that, of course, is in dollars. In number 5, we talk about mail volume, and the mail volume of U.S. first-class single-piece mail decreased from about 42.3 billion pieces in 2007 to 19.7 billion pieces in 2016. What was the percent decrease? So let's familiarize ourselves with this problem. And so the first thing we can say is we find out by how many billion of pieces the mail volume decreased. So in other words, 42.3 billion in 2007 minus 19.7 billion in 2016 means the decrease in mail volume was 22.6 billion. Now let's translate this. And so the question is 22.6 billion pieces of mail. So we translate the sentence 22.6 is what percent of 42.3? 22.6, and the is means equals, and what percent is P of is multiplication 42.3. In proportions, we write it as n divided by 100 equals 22.6 divided by 42.3, where n percent equals P. So now we solve the following percentage equation. 22.6 equals P times 42.3. We divide both sides by 42.3, so 22.6 divided by 42.3 is equal to P. So in other words, 53.4% is approximately equal to P. That is rounded. It's actually 43.427896. And when we solve the proportions, we cross multiply. So 42.3n cross multiplying 42.3n equals 100 times 22.6. To isolate n, we divide both sides by 42.3, so n equals 100 times 22.6 is 2260 divided by 42.3, and so n is approximately equal to 53.4. To check, we can multiply 53.4% times 42.3 billion, and that's equal to, well, approximately equal to 22.58 or 9 actually, round up to 22.59. And that's reasonably close to the actual decrease we computed before of 22.6 billion. Let me just move up here. 22.6 billion was the actual decrease, and of course 22.59 is very close to 22.6. So in other words, the calculations are correct. 53.4% is the percent decrease. So let's formally state that at the conclusion of this exercise. So our final answer is the percent decrease was about 53.4%. We familiarize ourselves with the problem by noting that in 2015, the amount spent was 4,015, and in 2014, the amount spent was 3,971. So the increase was $44 for increase in spending for groceries. So that's P be the percent increase. we translate this into the following equation. 44 rather, the increase is what percent of 3,971. So numerically it means 44 means equals, and percent, what percent? It's P of, that's multiplication, 3,971. Or if we use proportions, n divided by 100 equals 44 divided by 3,971. The percentage equation then is equal to 44 equals P times 3,971. We divide by 3,971 on both sides to isolate P. So we only have P on the right side, and we have 44 divided by 3,971, and that's equal to, so 0.011 is approximately equal to P, or what, 1.1%. When we solve the proportional, here the equation with proportions, we cross multiply, and we get 3,971 n equals 100 times 44. We divide both sides, oops, is the n missing. We divide both sides by 3,971, so then n is isolated, that's equal to 4,400 divided by 3,971, and that's approximately equal to 1.1. To check, we take 1.1% of 3,971. So 1.1% of 3,971, or 0.011 times 3,971. That's equal to 43.68. And that's reasonably close to the increase we had computed earlier as $44 increase in the difference between spending these 2 years. So 43.68 is close enough. And so therefore we can state our result. So the percent increase in the amount spent on groceries was about 1.1%. This is the end of section 6.5.